The general conviction among most experts is that the speculation of how things came to be stays the major clarification for the early times of the universe. This hypothesis joins the development of stars, planets, and, in this way forward, life on those planets, including ourselves. Regardless of its odd name, the Big Bang offers an edifying examination concerning what could have occurred at first. The universe was thick in a short space, more thick than a pinhead, with particles thickly squeezed. From this second, a giant effect of matter and energy occurred, known as the Big Bang. This event, happening billions of years prior, set up the fanning out of inestimable history. In any event, in reasonable information, it has set off making idiosyncrasies with the doubts of this hypothesis. Right at the point when NASA shipped off the James Webb Space Telescope, the largest and most advanced space science observatory of all time, experts anticipated that its understanding would confirm the hypothesis of the universe's start stage. Unfortunately, after only a single year in space, the telescope shocked experts with its ability to peer so deeply into the universe's past. The James Webb Telescope's astonishing limits have uncovered innumerable universes, going as far back to a time so old that it challenges how we could interpret the universe's beginning stages. This openness has started a serious evaluation concerning what existed before the Big Bang. One huge moment in this mission happened when cosmologist Rohan Natu, working with data from the telescope, suddenly found a system from just a brief time after the Big Bang, making it the most distant universe at any point seen. Natu's discovery sent shockwaves through laid-back experts, highlighting the surprising abilities of the James Webb Telescope. Its massive potential to affect our perspective on the universe has hardly started, promising to reveal amazing bits of insight into the earliest seasons of the universe's existence. This period, barely connected to earlier holds, is the key to understanding the development of the first stars and galaxies. The telescope's discoveries have clashed with head theories, revealing systems with attributes that outsmart past presumptions. This incredible flood of early universes has touched off a tempest of scientific inquiry, testing experts to adjust these revelations to existing speculation. As examiners uncover these openings, they face key questions about the very nature of the universe and the powers that formed its development. Beyond the James Webb Telescope's advantages, which are clear, it is viewed as 1.5 million kilometers away from Earth, safeguarded from boundless impedance and cooled to approach absolute zero by its tennis court-sized sun shield. The telescope joins an enormous primary mirror and incredibly fragile instruments, designed to uncover details of the early universe that were previously secret. This period, known as the Great Dawn, occurred around 200 to 300 million years after the Big Bang, marking the event at which the first stars and galaxies began to form. The interaction by which this unfurled remains a subject of intense inquiry, with theories ranging from the effects of dark matter and dark energy to the interactions between star-forming gas and dust. The telescope's perspective on galaxies from the Great Dawn presents a unique opportunity for cosmologists to test how they might interpret these complicated elements. By considering these ancient systems, specialists can either confirm the validity of their current models or uncover gaps in understanding that could lead to major new discoveries. The telescope was expected to observe a few weak and small galaxies in its pilot studies. However, reality has far outperformed these expectations. The telescope's early images of the distant universe revealed an abundance of galaxies with ages, sizes, and radiances that tested all estimates. This shocking surge of early galaxies has sparked a race among space experts to set new benchmark records for the earliest known mass systems, with new revelations emerging constantly, leaving conventional specialists in awe. Following the James Webb Telescope's discoveries, informed specialists and spectators have rushed to concentrate on the presence of these remarkably advanced early galaxies. Some hypothesize that mistakes in how the telescope might interpret huge perceptions could be liable for these surprising discoveries. That said, the agreement remains that these revelations represent a paradigm shift in how we could interpret the early universe and offer exciting impressions into the potential for massive change. The new discoveries from the James Webb Space Telescope about galaxies have raised huge questions about the nature of the universe and tested the assumptions of standard cosmological models. While some specialists are exploring whether these insights can be reconciled with existing theories, others suggest that they may be the first signs that the universe is far more complex and confusing than previously envisioned. The critical inquiry at play is our essential understanding of how the universe we know emerged out of early-stage turmoil. The early discoveries of the JWST could reshape our core thoughts about Big Bang history, revealing insights not just into distant galaxies and ancient structures but also into the very nature of our own Milky Way. As Mark McFan, Senior Scientist for Science and Exploration at the European Space Agency, puts it, "You build these machines not to confirm theories but to break them. You simply have no clue how it will break." The beginnings of the JWST can be traced back to the Space Telescope Science Institute, STSCI, in 1985, even before the Hubble Space Telescope was launched. At that time, G. Weir, then head of STSCI, was tasked with imagining what could come after Hubble. Despite initial doubts, Weir and a small group began laying the foundation for what would eventually become the James Webb Space Telescope. Unlike Hubble, which primarily captures visible light, the JWST was designed to observe in the infrared range, allowing it to peer much further into the universe. This capability is crucial for studying distant galaxies, whose light has been stretched into the infrared due to the expansion of the universe, making them invisible to telescopes like Hubble. With its vast cold, star-like mirror, the JWST became the essential tool for uncovering the secrets of the Great Dawn. The need for the JWST was highlighted in 1995 when the Hubble Deep Field observation revealed countless galaxies in what was once thought to be an empty patch of sky. This discovery illustrated the richness of the early universe and emphasized the need for a telescope capable of studying much further into cosmic history. After years of development and a cost of around $1 billion, the JWST was finally launched on December 25, 2021. By July 2022, it was ready to begin its most crucial year of scientific observations. Early initiatives, such as the Early Release Science Program and the General Observing Program, were specifically designed to search for early galaxies. While initial expectations were modest, the results far exceeded them. JWST observations have tested existing models of the early universe, uncovering galaxies that challenge conventional cosmological assumptions. These stunning discoveries highlight the importance of pushing the boundaries of scientific inquiry and showcase the extraordinary capabilities of cutting-edge innovations like the James Webb Space Telescope. As researchers continue to analyze JWST data, they may uncover further insights that challenge and expand our understanding of the universe. When the first data began rolling in from the JWST, cosmologists eagerly anticipated the results. Many had been preparing their data analysis pipelines for this moment for years. Instead of following the traditional peer review process, which typically takes months, scientists chose to share their findings on preprint servers like AR14, a platform for research papers that have not yet been peer-reviewed. This approach allowed a new type of peer review to take place through online platforms like Twitter, where established experts could quickly discuss findings. Rohan Natu described this process as science by press release, and the ensuing storm of conversation was both intense and astonishing. However, there were concerns about the potential downsides of this rapid dissemination of results. Klaus Pontypool, a JWST project scientist at STSCI, warned that while the fast sharing of results facilitated quick distribution and discussion, it also carried the risk of overwhelming the process. The rapid spread of discoveries, particularly in such a landmark mission, posed challenges to traditional scientific processes. The general consensus among most subject matter experts is that the speculation of how the universe came to be remains the essential explanation for the early stages of the universe. This speculation involves the development of stars, planets, and life on those planets, including ourselves. Regardless of its odd name, the Big Bang provides a compelling explanation for what might have happened at the universe's initiation. The universe was densely packed into a space smaller than a pinhead, filled with densely packed particles. From this moment, a huge explosion of matter and energy occurred, known as the Big Bang. This event, happening billions of years ago, set the universe's unfolding history into motion. However, as scientific knowledge advances, it has raised inconsistencies that challenge the assumptions of this hypothesis. When NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever built, researchers believed that its observations would support the theory of the universe's origin. Unfortunately, after only 1 year in space, The telescope shocked scientists with its ability to peer so deeply into the universe's past. The James Webb Space Telescope's remarkable capabilities have revealed galaxies dating back to a time so ancient that it challenges how we interpret the universe's origins. This discovery has sparked intense debate about what could have existed before the Big Bang.